Great. Well, in the interest of time, I'm going to get us launched here. So as I mentioned, I am Mackenzie Lyon. I'm the Vice President of External Affairs for Perpetua Resources. And thank you for joining us today. This webinar is an opportunity for us to share some of the key takeaways regarding the infrastructure required for our proposed Stibnite Gold Project and where we are in the NEPA process. So we are very excited about the fact that the U.S. Forest Service just released the supplemental draft environmental impact statement in October, and in doing so, identified our modified project design as the preferred alternative. This signals strong momentum for the project, but we really couldn't be also more proud of the work that we've done over the last 6 years to refine the project based on public, regulator, and stakeholder feedback. So before I turn it over to Jordan Nielsen and Jean Bosley, I'm going to take a moment to review the project and where we are in NEPA. So to start, as many of you may know, our project is located in central Idaho, about 4 hours from Boise in the Payette National Forest. Next slide. And if I were to summarize our project, I would say that the Stibnite Gold Project is unique for 3 reasons. The first is that it is located on an abandoned mine site that is in desperate need of help, and our project is designed to make the site better than it is today. Secondly, the Stibnite Gold Project will be the only U.S. mined source of the critical mineral antimony, which is critical to both our national defense and the clean energy transition. But today, the antimony market is controlled by China, Russia, and Tajikistan. And finally, we have and will continue to prioritize community partnerships and environmental responsibility alongside the safe and economic production of the minerals our country needs. And this approach is what responsible domestic production looks like. Next slide. So it really is a very exciting time for Perpetua Resources. Moving this project forward has been a labor of love, but it has absolutely been worth it. After the last 6 years of regulatory review and public feedback, this project is improved, and we're proud of it, and it is ready to move forward. The project will provide a net benefit to this historic site, leaving water quality, habitat, and rivers better than they are today. And finally, it is more critical than ever that we regain control of our critical minerals like antimony that are urgently needed to support the clean energy transition and national defense. But before we start talking about the future of Stibnite, I'd like to take a moment to help us understand the history of the site. So the history of the Stibnite mining district has a long history that goes way back to 1899, when mining first started for silver and gold in the district. But on the eve of World War II, the United States did not have a source of tungsten and antimony needed for the war effort. But the government found a supply at Stibnite, Idaho, which then went on to produce the majority of both minerals for the war and is credited for shortening the war by a year and saving 1 million American lives. This is just how important it is to source minerals here at home, not only to our past, but absolutely for our future. However, while we can be really proud of this history, there were many environmental legacies that were left behind. So water is heavily degraded with arsenic and antimony from millions of tons of legacy tailings and waste that were left behind. The headwaters of the Salmon River flows into an abandoned mining pit, which has blocked fish migration for over 80 years. And really just generally, habitat conditions are overall just degraded. And this is where we can come in. Because while being a brownfield site, we also know that there are robust mineral reserves still available at Stibnite today. The project economics are built on a reserve of 4.8 million ounces of gold, which makes it possible to access the 148 million pound antimony reserve and makes it possible to address the legacy features still left at Stibnite today. And antimony production matters because we're vulnerable without a domestic supply. Today, China, Russia, and Tajikistan control 90% of the global supply, and we have no primary mined source here. But we need it, and we need it because antimony has long been essential in doing things like strengthening alloys and making them resistant to corrosion. It's essential as a flame retardant. It plays a role in solar panels and semiconductors and wind turbines, and is used in the primers for many military munitions. It's also key to this emerging liquid metal battery technology that's needed to get clean energy onto the grid. And just this year, Congress took note and added an antimony reporting requirement to the National Defense Authorization Act. And this year, the Defense Logistics Agency also awarded Perpetua with 2 grants to study antimony from stibnite for defense uses. So while we have always known that if a modern mineral redevelopment were going to happen here at Stibnite, we would need to design a project that addresses the abandoned environmental legacies and bring value to our communities. Oh, sorry, Alyssa, you can move forward 1 slide. And so this has been the vision that has really driven the last 12 years for our company, and we've been moving it diligently forward through the permitting process. Next slide. So I want to just provide a really quick overview of how our project has been refined and developed through the NEPA process. So essential to our design of the Stibnite Gold Project is the plan to advance environmental cleanup of the legacy conditions as we mine. So this includes reconnecting the anadromous fish migration routes that have been blocked for 80 years, and also picking up, reprocessing, and safely storing the legacy tailings and the waste that's been left at site in order to help improve water quality. We've also designed this project with community feedback on everything from site access routes that you'll hear more from Jordan about, to doing our part to reduce light pollution. So in 2016, we submitted our project to the U.S. Forest Service to launch the review under the NEPA process, the National Environmental Policy Act. And we are now in our 6th year of review under that process. Importantly, in 2020, the Forest Service released the draft environmental impact statement for a 75-day public comment period. And now, just a few weeks ago, on October 28th, the forest released a supplemental draft environmental impact statement for public review and comment. And now we are quite hopeful that we will see a record of decision in late 2023 or early 2024, which would put production in about 2027. Next slide. And I really can honestly say that while the process has been long, it has helped. This process of rigorous scientific review and public input and revision has improved the environmental and social aspects of our project. So for all the public comments that we heard on that draft environmental impact statement in 2020, there were over 10,000 comments from the public and tribes and agencies. And we listened. And what we heard was that we needed to find ways to improve water quality, to reduce water temperature, and reduce our project footprint. So we made modifications to our plan, and all geared at improving these environmental outcomes. And so these changes, which include things like shrinking the size or the volume of Hanger Flats pit by 70% and completely backfilling it, or adding geosynthetic covers on pits and backfills, and the Tailings Storage Facility buttress to improve water quality, or improving our ore processing to reduce mercury and to stabilize arsenic in tailings. All of these changes that we've put into the project are now available for review under the supplemental draft environmental impact statement, in which our modified plan has now been identified by the Forest Service as the preferred alternative. And it compares our plan with our proposed access route using Burntlog Road with the plan, but with using the current route to travel to Stibnite, which we call, or the document calls, the Johnson Creek route alternative. So those are the 2 things being compared into this document. Next slide. And so in this process, the Forest Service has now identified, as I mentioned, that our proposed plan using the Burntlog Road is their preferred alternative. And in doing so, they established that our proposed plan, the modified mine plan, meets the purpose and need required under the regulatory framework, that we've improved water quality, that we've eliminated the need for permanent water treatment, that we've improved water temperature, and offer through Burntlog Road the safest route for people and the environment. So this is a lot of work and we're really, really proud of it. But I'm now going to turn it over to Jordan and then Jean to walk through some of the infrastructure associated with the project as it's designed now.
Okay. Can you guys hear me?
We can.
I can't turn on my video for some reason.
All right, we'll work on that, but go ahead and get started.
Okay. My name's Jordan Nielsen. I'm the infrastructure projects manager. I'm going to be focusing mostly on offsite infrastructure. And Jean Bosley, following me, will be on discussing more of the on-site infrastructure. Next slide, please, Alyssa. Okay, so I kind of want to give just an overview of most of our offsite infrastructure that we're proposing to either build or upgrade. What we see here is really a good portion of Valley County, Idaho, north of Boise, about 100 miles. On the western part of this figure, you have Cascade in the south and McCall to the north. And what you see in purple here is the proposed transmission line upgrade. What you see sort of on the eastern side is the Burntlog route that I'll be talking about later. As well as a couple of other upgrades that we're proposing. I won't discuss too much on this, are some intersection improvements along Highway 55, which is the main north-south corridor through Idaho and provides sort of a jumping off point for our site. And where we would jump off is basically at Cascade, the intersection of Warm Lake Road and Highway 55. I'll highlight one section here over, trying to show my arrow. Okay, got a pink arrow there, so I'm gonna have to use to kind of point certain features out. But okay, it looks like you can start my video now. All right, here I am. Hello, everyone. So we're also going to discuss the Burntlog route maintenance facility. Also, as we get up towards site, in this area here, we're discussing the worker housing facility, as well as down here closer to Cascade, the Stibnite Gold Logistics Facility. All right, Alyssa, next slide, please. Okay, so first I want to start on access, and I'm really going to focus on our proposed access route, but Mackenzie did mention the Johnson Creek route alternative. That's this sort of north-south black road out of Landmark and meets up with Yellow Pine. At Yellow Pine, it then heads east into Stibnite along the Stibnite Road. What we're proposing is at Landmark, we would head east. We would upgrade a portion, about 20 miles of the existing Burntlog Road. We'd widen it more or less to, its average is about 14 feet wide now. We're looking at a running surface about 20 to 21 feet. So we would upgrade a good portion of that, about 20 miles of that, and then we would connect the end of Burntlog Road to the Meadow Creek Lookout Road, which is up in this area here, with about a mile of existing road that we would upgrade there. And then we would add an additional 4 miles of pioneered road that would get us down into Stibnite. So a few things that we looked at when we were looking at different alternatives, and we looked at more than just the Burntlog route and Johnson Creek route alternatives. We did a lot of trade-off studies of other potential routes into site that eventually kind of worked their way out of our favored location for various reasons. And so I'll just focus on kind of the positives of Burntlog versus Johnson Creek. And really the biggest thing is that the Johnson Creek route parallels for many miles Johnson Creek and Stibnite Road and the East Fork of the South Fork along Stibnite Road. Those are fish-bearing waterways. There's a lot of recreation traffic along those roads, especially during the summer, and we didn't want to impact those. There's also lots of issues in the winter or late spring with avalanches. Those are at the bottom of drainages rather than up at the top where we're proposing with the Burntlog route, which puts us, puts passenger vehicle traffic at risk when trying to get to site. What we found out, some of the safety considerations that were kind of, we've looked at were that all the sensitive loads would travel, along, we would prefer that they travel along the Burntlog route than along paralleling streams. What I do want to kind of point out, one of the things that we've heard a lot from now is that our proximity to the Frank Church, it is in this area here, fairly close to the Frank Church. The only portion of the road, the proposed road, that would, I guess, drain or report to the Frank Church is the one, it's about a mile-long section on the existing Meadow Creek Lookout Road. And what we've proposed is, to upgrade that section of road, but when we build the road, the grading of the road will report to the north rather than to the south and away from the Frank. There's another portion here that's highlighted by the pink arrow, also just west of the Frank. It's about a 3 mile long section of new road. That section is on the western side of the ridge. People are concerned about spills. If there was a spill in this area, it would not report to the Frank. It would, in fact, report west and north towards Reardon Creek and eventually. So, let's see if I have a few more. I think that's it for this slide, Alyssa. Okay. This, as you recall, so I'm going to talk about the logistics facility here. This is located approximately 7 miles east of Cascade along Warm Lake Road. This is an area where we'll have our administrative buildings, as well as our transportation facility. This is, was chosen due to its proximity to Cascade and the rest of, sort of Western Valley County. It allows for those folks to work here to have, basically work a regular shift, from 8 to 5, and could stay or live in Cascade or McCall. Whereas at site, we're looking at a 2-week on, 2-week off sort of schedule. But what we have located here are kind of our human resources building, purchasing, accounting, and administrative offices, as well as warehousing, storage, and our laboratory. But what we like about this location from a traffic and access perspective is, rather than have all of our workers drive by themselves into site, we'd like them to park here. We've proposed and talked about it internally as, people can drive from anywhere to park here, or, what we would hope also is in the future is that we would have some sort of public transportation that could pick people up along the Highway 55 corridor, even as far as maybe New Meadows, and bus them to these locations. And what we're looking at is basically busing everybody from this location to site to reduce the amount of traffic on the roads. We've said that during operations, we're looking at about 50 vehicles on average per day, additional to the existing traffic that we see. We think that's important because that reduces, the potential for dust and sediment generation that could impact some of the streams in the area. Also, obviously reduces the amount of potential for accidents along this route, and reduces greenhouse gas emissions. Next slide, Alyssa. Okay. So as part of our plan is we would like to concentrate traffic between 5 a.m. and 7 p.m. Monday through Friday. For any of you that are maybe not aware of this area, it's a very active. Warm Lake Road is sort of access to a lot of recreation to the east, sort of where our site is located. And it picks up Friday afternoon through Sunday, as you can imagine. So we'd like to concentrate our traffic kind of opposite that schedule as to not provide too much impact. I touched on these two bullets. One of the items too is at the logistics facility is that's where all of our I say heavy vehicle traffic would check in, whether it be some of them that need to drop off, and so that we can aggregate loads before we head out there to minimize traffic on the roads, or to provide a pilot vehicle for some of the more sensitive loads. And that way we can monitor, obviously weather conditions and go at the most reasonable times to reduce risk to any sort of vehicle crash and potential spills. Other couple things to note are sort of we hear a lot about the impacts of our traffic. Sort of down here at the bottom is, we're expecting a 1 to 3% increase in the traffic counts based off our project. And why it's 1 to 3 is, we see a smaller impact north on Highway 55 going through McCall than we do from Boise to Cascade. And then obviously we'd see a little bit larger impact on Warm Lake Road just due to there's less vehicle traffic than Highway 55, but it still is it's a little over 3% increase from what our current. Like I said, I touched base on the intersection improvements because we're planning on using Highway 55. We've been working with the Idaho Transportation Department to improve 3 intersections. One of them is at the intersection of Highway 55 and Warm Lake Road. That one is really with a partnership with Valley County ITD and Perpetua. We're looking to add some sort of deceleration and some turn lanes and some some acceleration lanes to kind of reduce the potential for some of our heavier vehicles causing traffic impediments. We're also working at 2 intersections through the city of McCall because we've proposed to utilize what they call the bypass. It avoids going right down through the downtown McCall, which is a really popular place most of the year, especially in the summer. And so we've been working with the city of McCall and ITD at those 2 intersections to improve the sort of turning radiuses of some of our semi-traffic that would be coming through here. We haven't completed those designs, but we're in the process of reviewing them. Next slide, please. Okay, so this is the Burntlog maintenance facility. I pointed it out on the first slide. This is about 4.5 miles east of Landmark. This is where we would provide summer and winter maintenance. This is where our crews would be basically stationed. We are proposing to put it in a borrow source. So we need construction materials when we're building the Burntlog route. We're proposing that instead of a fresh or new location, we'd like to utilize one of our borrow sources to build this facility. This facility will have an aggregate storage building, a fuel station, covered structure for some of our vehicles, for winter maintenance and summer maintenance. Yeah, that's it. That's it for that. Next slide, please. All right, so the worker housing facility is located about 2 miles south of the process facility. It's down here on the, let me point it out here. This is where the Burntlog route access would come into the site. There's a gate, a security gate up here. So our vehicles would come in here kind of on the south end and drop off all of our workers here. And then they would obviously get to site utilizing an upgraded portion of Thunder Mountain Road, which I just pointed out. I mentioned it earlier, but I'll say it again, is that we're proposing a 2-week on, 2-week off work cycle. We think that works well for people that don't necessarily live right in the area and can maximize time with their families. So the facility will, it'll ramp up, it'll be pretty large during construction, because that's when we anticipate the most amount of people on site. So we'll probably ramp up, have about 500 people, facilities for 500 people, and we'll reduce the size during operations down to an accommodation of about 350 or so. Next slide. Okay. Thank you, Alyssa. So I think this is my last slide. This is a discussion of our transmission line upgrade. We've been working with Idaho Power to design about 72 miles of transmission line. About 63 of the miles exist already. It's a current transmission line route that provides power to the village of Yellow Pine. Warm Lake is a small village or small area, recreational area too, that it provides power to. And so what we've been working on is there's several substation locations that we would need to upgrade. And it really begins at the origination all the way to Hell's Canyon and the Oxbow and Horse Flat substations. But we also are looking to improve substations along the entire route. So City of McCall will see an upgrade. The Lake Fork substation here, which is between Donley and Lake Fork, would also see an upgrade, as well as the one here at Warm Lake. But we're also proposing several new substations. One being here down at Cascade. This is a sort of a junction point between where the one, okay, I should step back one moment though, is we are upgrading this line to 138 kV from its existing capacity of 69 kV. This location is sort of a junction point where we have the 69 and 130 kilovolts coming into one location. So it's a switching station here. And at this location, we're also proposing a reroute. We, during scoping years ago, heard from several landowners sort of in this location here. There's a subdivision that goes, that the transmission line crosses. They didn't want an upgrade, so we looked at alternatives. So we decided to move the line out of the subdivision and onto public land to avoid their properties. So that's more or less in that location there. We're also looking to build a new substation here right at our logistics facility that will provide power to the logistics facility, as well as a few domiciles that are nearby. There's a new substation in this location called the Thunderbolt Tap. It provides power to a microwave facility. And then we have one here along Johnson Creek, and that will basically be the jumping off point to Stibnite to the east. I think what's important in what we have here on the slide is that the costs will not be incurred by Idaho Power ratepayers, rather Perpetua resources. And this is a very snowy area. A lot of this line was originally built back in the 40s, so it does have issues. It does at times lose power. So it will be a new facility and therefore a lot more robust. So there's a couple other options. We have it's not a great graphic here on the right, but what we're proposing is sort of a like for like. We're not trying to create really any new disturbance. Due to the forest fires down in California in the last few years, there has been a request that we widen the right of way to prevent damage to the lines or even the fire, the lines creating fires. So the right of way through the mountainous areas will be increased from 70 feet to 100 feet. And the structures, as you can see on the right, the majority of those through the mountains are what are called H-frame structures or three-pole structures. Those will increase in height slightly up to 20 to 30 feet, but width-wise will remain more or less the same. Everything down in the flats will also remain a single pole structure. It will also increase in height, but not width. I think that's all I have for my presentation.
Thank you, Jordan. We'll turn it over to Gene.
Thanks, Jordan and Mackenzie. So I'm Gene Bosley. I'm a senior engineer at Perpetua Resources and led some elements of the feasibility design for the site components I'll talk to you about next. First of all, and Mackenzie covered a little bit about this. This is just the mine site layout. Obviously, we've got quite a bit of infrastructure to build. We've road and power, Jordan covered very well, but we've of course got a lot of things to do on site to facilitate mining and ore processing. I won't dwell on the roads. There are, of course, as you see here in the gray lines, plenty of internal roads within the site that are, pretty conventional road building principles. Those will be gravel surfaced roads or rock surfaced roads. They won't be paved with asphalt or anything of the sort. They'll be, 100 or so feet wide for our main haul roads. And we, of course, have a lot of access roads that go on down to 20 feet wide or so for light vehicles. And those are kept separate for safety's sake. And also kept separate from the public road. There's a public access road you see here in the northern part of the site. It goes up and around the Yellow Pine pit, and that will facilitate public access through the site, grade separated from any mine haul traffic. We don't want folks mixing with haul trucks, 150-ton haul trucks. It just wouldn't be safe. So we'll control access, but we'll control and escort, but allow public access through site throughout our operations to access, Thunder Mountain and points east in the Frank Church wilderness area. So that's it for roads. The other three key pieces here are one, the fish tunnel. We'll not cover that here today. That'll be covered in the River and Fish webinar coming up here in I think next week or the week after. The next one is the ore processing facility. That is the centrally located area there, right where the power and roads kind of come together, right in the middle of this map. And that's where, we will take mined ore and process it and end up with gold and silver doré, which is just bars of unrefined gold and silver, as well as an antimony concentrate. And then once one does all that ore processing, you've got tailings left over, and those will be stored in the tailings facility, which is on the southwest corner of this map here. And we'll go into the ore processing and tailing on the next slides. Okay, so the ore processing, I mentioned doré. That's again just a mix of the gold and silver. We do not have great silver recoveries, but silver, of course, is worth about 1/80th of what gold is worth. So we focused on gold recovery above all else in our process design. And we do pretty well there at 89% average recovery to doré. And again, that's, 4-ish million ounces of gold over the life of the project. Antimony, we recover it as the mineral stibnite, which is what it is in the rocks. We recover that. We recover a very pure stibnite concentrate with a little bit of gold and silver, which we get as credit when we send that off to a buyer. They will recover that gold in their process while they process the stibnite to produce antimony metal, which Mackenzie covered as far as its myriad uses. And again, our concentrate is quite high grade, nearly stoichiometric stibnite in a few cases. And once it's downstream of there, of course, there's a few options: smelting, roasting, hydromet. All of those are to be determined. Those are the province of those who we will sell the concentrate to at the moment. Those are not part of our project itself. We sell, again, concentrate, not pure metal. As to how do we do it, how do we get there, right? So, of course, ore comes from the mine. At up to 24-inch or so particles. It's blasted, loaded into a truck, truck to the mill, dumped into a crusher, gets it down to a few inches. I think it's a 7-inch crush or so. That feeds what's called a sag mill. That's semi-autogenous grinding. And what that mill is just a big rotating drum where the rocks bang into each other to be broken up in addition to the balls that are in the mill. That goes on to a ball mill where there are metal balls in the mill that help grind the rocks. And that grinds it down to an 85 micron or so size. After that point, well, we do a process called flotation, which is really where you add a few chemicals to help stabilize air bubbles and to help metals or make metal minerals stick to the bubbles, bubble air up through that slurry of metal and water, of ore and water, and skim off the froth from the top, and that becomes your concentrate. The first step for us is to recover that stibnite concentrate where the antimony lies. So that stibnite or antimony sulfide is concentrated, dried and bagged, and shipped off as a concentrate. Downstream of that, or directly to pyrite if there is no antimony in a particular ore stream. Downstream of that, we go through flotation again, but this time we're trying to float pyrite, and that's just a matter of using a different reagent to help the pyrite stick to the bubbles instead of sinking. That concentrate then goes through what's called pressure oxidation, or POX. And what that does is it breaks down the pyrite into sulfate and free metals. And in our case, our gold is all very fine gold. It's disseminated throughout our deposit and is locked up inside those pyrite grains. So we have to cook off the pyrite and break down those minerals to liberate the gold. And then we go on downstream to the cyanide leach process and electrowinning and all the standard things that really almost anybody is doing to recover their gold. It's just that we, because our gold is locked up in those pyrites, have that first POX step after concentration. And that's the main line of our process. Now you see some dotted lines on here. You see the oxide lines. We have a lot of transition materials in our third pit. Those go through flotation partly, but those flotation tailings will still be leached because there is some oxide in the transition. That's what we mean by that transition. It's mix of oxide sulfide. Oxide materials, well, those go straight to gold leach. There is no reason to float them because oxide gold doesn't float. There's no way to concentrate it. You just go straight and leach the whole ore stream. And so that's in a nutshell how our process works, how we get the metal out. Next slide, please. Okay, that's just the intro slide. So when, after all this processing, of course, you're left with tailings, right? I mean, we have 22,000 tons per day of ore processed. It's only, a couple of grams per ton there is gold. So a few grams of gold in every ton end up in doré, and then some number of percent, a few percent antimony by mass, depending on what ore we're working that day, ends up in the antimony concentrate. The rest of it is the ground up rock with the valuable minerals removed from it. And that's what tailings is, right? And we have to have a place to put those. The tailings, of course, are mixed with processed water. This is all a water process here throughout the plant. Everything is a slurry with ground up rock mixed with water. And that's how we get it to the TSF as well, is we pump a slurry. That slurry arrives at the TSF. Some of the water separates. The rest of the water is entrained in that tailings mass. And then we keep adding more and more tailings to it. And the tailings that were already there consolidate, give back more water. And we pump that water back to the mill and recycle it. It's called what we call reclaim in our business. So essentially it's a big circle. We pump water out with solids mixed in. The solids are retained in the facility. The water comes back. Now, that entails a few considerations, right? Is that water is, of course, processed water. That water has residual cyanide, though very low levels, because we don't want cyanide. It compromises the effectiveness of that flotation process I mentioned earlier. So the cyanide gets knocked down before it ever goes to the TSF, but there is some residual. And of course, that POX process liberates a lot of things. Now we do what we can in the mill to stabilize them. We have what's called a hot arsenic cure that makes the arsenic form insoluble compounds going out with the tailings, but there's still some that will be soluble. And so we can't allow that processed water to leak out of that facility, and we can't allow that facility to be unstable. And so that's where a lot of these design considerations and configuration decisions that you see listed here come from. Is it's a matter of assuring the long-term operational phase as well as long-term physical and chemical stability of the facility and the tailings that are stored within it. And where that goes here is, you see on the left a few colorful lines. I apologize, anyone's colorblind. The red line is the limits of our liner. But you see, we want to keep water out. We don't want clean water rolling into the facility and becoming processed water. So we divert Meadow Creek and its tributaries all around the facility. Early days, we don't have one on the north side. There's not much water there, but second phase, we do put a diversion in. So we have full perimeter diversions. And we have a lined facility, again, fully composite lined in the impoundment, as well as the dam face. It's all one continuous liner. And further on water management is we leave a very large freeboard. We have a freeboard sufficient to store what's known as the probable maximum flood, that being the biggest flood that could occur in a given spot. In our case, that's generated by about 12 inches of precipitation on the watershed in 24 hours. Somewhere in the Philippines, that number might be 3 meters of precipitation. In our case, it's 12 inches due to our locale and our climate. So that at all times during our operation, that facility will always have the reserve storage to hold on to that probable maximum flood should it occur. And that is from the whole watershed. We don't take any credit. We build diversions, but for that super flood, we don't take credit for them. We have enough storage always available that we could get a foot of rain on the entire 6 square miles that is above that facility and store all of it without spilling a drop. Plus a little extra is another 4 feet on top of that. So that's really the water management philosophy here. It is a zero discharge philosophy during operations, is we will store whatever may come. So that's the containment. Now, to stabilize that in containment, you need a dam. In our case, it's rock fill. So we have rock comes out of our mine pits. We compact that and form an embankment with that. Some of that is legacy heap leach ore. Some of it is just pit run rocks. Some of it is alluvium that we dug out of the bottom of the impoundment when we were building it. So you build, a large rock fill dam. In our case, it's about 67 million tons of rock that ultimately go in there. Also in our case, and we see that here in, east of the dam in the image to the left, we also have a buttress that we put in front of that dam. Now that buttress is actually 80 million tons. Ultimately, it's larger than the dam itself. And where that gets us to, and we'll see the stability work in a minute, where that gets us to is a dam that's not going to move come what may, as far as earthquakes or whatever, right? It's stable in its own right. Then it also has that buttress to keep it from moving if anything should happen as far as a very large earthquake. And then, yeah, I think I covered all that. Next slide, please. And here's that stability analysis. So, this is the example of the ultimate facility. The results are similar for all the other phases. I'm just showing one for simplicity here. The top image is the standalone facility. Now, the minimum factor of safety for Idaho for dam safety is 1.5 for static. We hit about a 1.8 for this standalone. And the thing is, a standalone never occurs. This facility will never be standing alone, but for maybe a couple of months early in its life before that buttress starts to grow. And I'll show you how that happens in a few slides. But just the hypothetical standalone dam meets or beats the regulatory standards. And the numbers for seismic are similar, all the way up to what's known as the maximum credible earthquake, which is similar to the probable maximum flood. It's the biggest conceivable earthquake in a given locale. Our MCE will not be the same as the MCE in, say, San Francisco. but it's a substantial one. It's about a magnitude 7 and relatively close to the site on the Deadwood Reeves Creek fault. So this dam is stable, standalone for static conditions as well as the MCE. Throw in that buttress, and that factor of safety goes up by double or more. In this particular cross section, it's 5.9. And doubling the factor of safety is not doubling the safety. Doubling the factor of safety is reducing the probability of failure by factors of 100 or 1,000. And in our case, we get up to something like 1 in 10 million annual probability of failure, which is essentially 0. And the other thing to note here is just the scale of these things, right? It's a large dam, of course. It's 400 some feet high ultimately. But the pool, the actual water, remember I said we pour tailings into the facility, pump them there in a pipeline, spigots discharge those tailings into the impoundment. The water and the solids separate to some extent, and we pump back and recover the water to recycle it, to reuse it in the ore process. And what that means is you have a rising deposit of mud that later becomes more like a soil as it consolidates, with a pool on top of it. But that pool is only ever a few tens of feet deep. The pool is very small relative to the size of the dam. It's not like a water dam where there might be 400 or 500 feet of water in the facility. There's not. It's a small pool sitting on top of a large deposit of what later essentially becomes a soil. Next slide, please. And then I mentioned the buttress. So here's just an indicator of how it grows. And the important thing to understand with the tailings facility is we don't build it 400 feet high at once. We build it, in our case, about every 3 years to keep up with to stay ahead of about 3 years of tailings deposition. And that's largely an economic question for us in mining. You don't build if you don't know. I mean, we're confident our mine will run its full life, but it wouldn't be wise to build it that way and build 400 feet of dam initially. Plus, we don't have rocks to build 400 feet of dam initially. We have the rocks that come at us from the pits when they come, according to the mine plan. So we build that first stage, you see in the top left figure. We build that initial phase and get to building the buttress in the stage 2 phase almost right away. Part of the consequence of some of the mine plan changes that McKinsey covered is that, we have a lot of rock coming at us early versus the old mine plan, because we've eliminated the Fiddle development rock facility, which was 168 acres disturbance savings. Well, that rock had to go somewhere. One place it goes is to fully backfill the Hanger Flats pit, which is now also a little smaller. But the other place it goes is this buttress now can grow very quickly. Year -1 is right before commissioning. We have a startup pool there. That's our initial inventory to get started with ore processing. Year 1, you've already got the phase 2 dam in progress, and you're starting on the buttress. Year 3, you've got the buttress having grown substantially down valley. That's the bottom right image. That buttress is now substantially down valley, meaning that the stage 2 embankment that's there in existence in year 3 is exceedingly stable, way beyond, again, what it's required to be or needs to be. And next slide, please. And then year 4, you see it growing again, right? You're moving down valley. Year 5, the buttress, you reach the stage 5 embankment elevation in year 5. So we don't need an embankment that big until year 12 or 11, but we achieve it in year 5. And then thereafter, there's not a lot of news going on. The buttress just continues to get a little bit taller below that elevation in the lower parts of it, and then it expands down valley a little bit. But what that means is, we very early have reached our full height in our bulk fill, which means whatever may happen, right? I mean, this happens all the time. Somebody decides, well, let's get a debottleneck the mill and increase production to 30,000 tons per day from 22. Well, if you do that, your facility fills faster. And if you don't plan it correctly, you can quickly find yourself behind the 8 ball on dam raise where your facility is going to fill before the next raise is otherwise scheduled. Well, because our buttress grows this fast, you've essentially taken, of course, stability off the table. It's whatever earthquake may happen, it's the dam itself will not move. But you've also given yourself the ability to, all you have to do is go and line the impoundment in the dam face and do the prep work associated with that lining work. You don't have to build, 20 million tons of dam fill. So we have really a lot of flexibility in our dam phasing as a consequence of the new mine plan and the buttress growing so rapidly. Next slide. And where this takes us is really this, right? Our facility, I forgot to mention, is downstream constructed, right? We always have rock on rock. We don't have new rock built on tailings, which is known as the upstream method. It is a rock fill. It's not soil fill, and it's not made out of tailings. It's tailings themselves. The tailings are stored behind the dam. They don't form a part of the dam. The liner is a complete composite liner. So that's more than one layer, right? It's a plastic, it's a geomembrane on top of a geosynthetic clay liner, which is the state of practice for tailings these days. It's been reviewed. We've got a third party, review team. We have that buttress. It, of course, is built and regulated in the U.S. The U.S. has a very robust dam safety program relative to, we really are the international standard for dam safety programs. And of course, that dam is but part of the perimeter. That 90% of the perimeter is not dam. It's mountains made of granite. So those are not going anywhere either. And where that takes us is, we know of no failures of a facility that has all these boxes checked worldwide. So next slide, please. And that's about ops, right? As well as long-term, everything that's stable in ops only becomes more stable long-term as the tailings consolidate. Tailings facilities, with few exceptions, are like a fine wine. They tend to get better with age. And one of those aspects in ours is once we transition it from operations into closure, and once we get that tailings consolidated so that it's drivable, we can put heavy equipment out on it, is we're putting Meadow Creek back on top of it. And that the full footprint will be lined now. It was previously just the stream corridors, but we'll have a geosynthetic liner on top of this to isolate everything from processed water that may come up. That water will be taken off and treated, and then discharged once it meets water quality standards. But Meadow Creek will be put back over the top of this tailings facility, and that will be in a corridor where the liner's at depth. It's down there 6, 8, 10 feet. On top of that is a series of layers to protect the liner from scour and to provide a floodplain and functioning channel that is allowed to move around within that, including allowing formation of alluvial fans, which is why you see these trumpet bells near the back of that green image, on the green part of the image there. Next slide. And here's just artist, and this is one of our internal artists. This is one of our mapping guys and multi-talented individuals we've got on our staff that developed this rendering. This is looking from the back of the facility down valley at the ultimate restoration vision for the tailings facility. Next slide. And here we are looking back up the other direction. The Hanger Flats pit, which is our second pit, is here on your right. The valley bottom part of that's all backfilled and restored. And then you're looking at that meadowy face there. That's the face of the buttress, as far as what that's going to look like at closure. And then next slide, please. I think that's onward to McKinsey.
That's over to me. Thank you so much, Jean. And thank you so much, Jordan. Alyssa, you can go to the next slide. So if that wasn't enough information for you, don't worry, we have a lot more. So we will have another webinar on the 1st of December at noon. This one will focus on river and fish and wildlife impacts. So if those are things that also interest you, tune in. We will also be hosting office hours. So these are opportunities where you can sign on to a virtual meeting and discuss the project with myself and many others from the team. So we want to make sure that if you have questions, we're getting you the information you're looking for, and that we can help answer those questions for you. The U.S. Forest Service is also going to host a number of open houses. This is yet another opportunity to find information about the project, to learn more, and to have your questions answered. So I very much encourage you to look into these options if we haven't satisfied your questions today. You can find out more by going to our website, perpetuaresources.com/webinar. Next slide. So there are great ways to stay informed. We also have more information on our website at perpetuaresources.com/SDEIS. You can visit the Forest Service's website to learn more about the project and to submit your letter there. Or if you are ready to submit a letter on this public comment period that is open until early January, you can do so through visiting supportstibnite.com. And this is a really easy tool that will take you just moments to share your opinion with the U.S. Forest Service on moving this project forward. If you go there, we ask that you take a moment extra and make sure to personalize that letter. So what are your experiences with the industry? What are your experiences in Idaho or with Perpetua that help formulate your unique perspective on this project? Let the Forest Service know, and let them know that it's time to move the Stibnite Gold Project forward. So with that, thank you so much, everyone, for joining us today. We will post this webinar and the deck on our website in the next day or so, along with the other technical webinars we will be doing as well. So as always, thank you. If you need anything, don't hesitate to reach out. And have a lovely Thanksgiving.